G'day Internet, welcome back. I know it's been 7 years, but we're back. We're doing a part 2 of the PyUHF series.
So ultimately, this video will be covering a number of different topics. We're going to be learning and creating our very own tone-based data transmission protocol, basically all the beeps and boops, just like dial-up modems and Meshtastic. Yes, before you comment, we are very aware that Meshtastic, BitChat, a whole bunch of other different projects, really cool projects, be sure to check them out, are currently existing. We know we're trying to do something different though.
Basically what we're doing is we've got UHF radios and we want to send digital data over those radios, kind of like an internet network. And the idea for now is to make it like a chat system, basically like a peer-to-peer network, except what we want to do is we want to have multiple radios in little like Raspberry Pi cases, and those will be like little repeaters or nodes scattered throughout any area.
We're going to be playing with the logistics of a decentralized node-based network or meshnet. We're going to be designing custom enclosures and hardware, custom PCBs, basically a Raspberry Pi and SDR hybrid without needing to have all these wires and stuff. Cool enclosure for it. You guys might be able to purchase on a website or download the files for you to make it yourself.
We also need to do some research in the ACMA. For those who are in the US, the ACMA is Australia's FCC to say, you know, what are we actually allowed to transmit on these general use channels? There are like data reserve channels, but I don't know what the data explicitly is, or if those are like privately owned.
We're going to be delving into the physics and engineering behind the UHF radio and all wave-based communications, ultimately finding out the limits of data transmission on the sub-gigahertz spectrum. Finally, we'll be wrapping up in a beautiful little bow, a GitHub project, complete with a beautiful UI chat and a whole bunch of other different things, because we might end up making it so that you can actually surf the internet, like IP-based internet on it. All the trimmings. This project will not only physically rely on developing a community, having nodes in the community network, won't work without nodes, but also rely on bolstering a community, you guys joining our GitHub, joining our Discord servers, getting involved in the project, and helping us develop it further. Ultimately, we want to decentralize the project too. We don't really want to be admins behind this. We want it to be self-regulating, just like the network itself. You guys get to join up and we all ultimately own it.
So what we've managed to do at the moment is we've made a Python, Bryn's made a Python script that can receive and transmit audio pretty well. And when I say audio, I mean data. It sounds like this. And it looks like this. You see you've got the preamble, which is like the handshake. You've got the actual data, which so far is just text. And that's it. And what we've managed to do is it'll send you type in a text message, it does a preamble to establish communication. It's basically like dial-up. It sends the data 4 times because it's going over UHF radio and there's going to be losses, interference, stuff like that. Once it's done, hopefully it sends a handshake back. So what was receiving transmits back and just says, yes, I've acknowledged this, and then we get a nice green tick of acknowledgement. Issues that we are currently facing is basically just code. It works, but it's not stable. We're having audio driver issues because we're using like USB sound cards and stuff, using multiple threads at the same time, which is not a very efficient way of doing it. So anyone well versed in Python is probably going to know what we're going through. It's all going to be on a GitHub, so you can check it out. And then the plan in the future is to develop this into ready to buy hardware boxes or like 3D printed files that you can then buy the hardware, 3D print the box, put it together, upload the code to it. Why are we doing this? 2 things. One, a passion project, because it's cool, and this is actually a project that we did many years ago and we're revisiting it. Also, independent, decentralized communication network. If the internet goes down tomorrow, I can still send a text message to my mates. How cool is that? Using UHF radios, because these are everywhere. Baofangs in your car, cheap ones from Big W, they're everywhere. Yeah, don't need a license. Well, in Australia, we've got the CB band. It's channels 1 to 80. That's 470 something megahertz, I think. This bad boy, I literally brought this like 2 hours ago. This is the Raspberry Pi 4 Model B, 4 gigabyte. I got this because it has a jack on it that I'm assuming is a audio in and out. It's a TRRS. Once we get it working with this, we're going to try put it onto a Nano or a 0W but then that'll require a couple of hats, like PCB extensions to use the audio, as well as the other use for this is going to be enabling the transmit. So like on a Baofeng radio, on most CB, like semi-professional CB radios, you've got the two headphone jacks, one's a 2.5mm, one's a 3.5mm socket. You bridge one of those pins to ground and it enables transmit, same as the clicky button or your stuff if you've got a little of those bad boys there on your shoulder. And if we can connect that up to like a relay or a transistor to simply just bridge those two together to tell it exactly when to transmit, because what we're doing at the moment is using the Vox function built into the radio. It works, but it's not dialed in quite well and it has a delay in turning off and on, and yeah. So we want to be able to precisely tell the radio when exactly to transmit. We're also going to be live streaming everything we do here in this workshop live on Twitch and YouTube. So you can interact with us. We can send chats. We're going to have a chat log and everything. And it's basically the whole project timeline is going to be live streamed and you can watch that back. It's also the ultimate behind the scenes because I don't have time to set up camera angles like this and constantly record everything, so why don't we just stream it live? You guys can see what's happening. And then also, you know, any other cool moments, eureka moments that we discover something or something starts working for the first time, you can be there for that moment. And that's pretty cool. So please join. It's free. You can watch anytime. We highly encourage it. And also, if we ask for help, you can put some suggestions in the comments and we will read all of them.
Communications device. Let's just listen to everything, shall we?
Yep.
You did. You need to do on this radio too. What did you do?
We've turned the Vox.
No idea.
Turn the Vox down to 1.
Oh, it's that loud. Boom! Immediately. Hello, Lucky One.
Yeah. So that's working.
Okay, the speakers, it doesn't like it. Speakers.
So I was having a look through the ACMA website, familiarising myself with the laws and registrations, and on this page here, Citizen Bound Radio Stations Class License, scroll down a bit, and it says right here, we do not allow packet radio and other types of data operation on CB bands. And you hover over data back and it says a method used to send packets of data. Now that's exactly what we're doing. They allow telemetry and telecommand. So the difference between telemetry is like reading sensor data from like a remote weather station and it's sending collected data over CB radio, and then telecommand is like telling a device to turn on or off using CB radio. But packet radio, which is data, which is we're sending text that's just for text messages. So as of this point, the project has come to a halt because we want to do the right thing and we don't want to break the law. These laws exist for a reason. I'm going to do more research and potentially send ACMA an email asking, this is what we want to do. How do we do it? We want to do the right thing and potentially get a license. The closest thing I found to a license so far from my own research is a public telecommunications service, PTS, which is the closest I can find. It wouldn't be an amateur apparatus or amateur radio license because that's just for talking. We're not talking, we're sending data. So what we're going to do is we're probably going to put this project on the back burner and maybe use the resource that we got, like the Raspberry Pi here, for other applications. If you have any suggestions or ideas, please leave them in the comments. We're open to anything. We still want to do something to do with RF.